lives in darkness. This unique feature creates stark temperature contrasts but may also foster complex weather systems. The planet's terminator line, where day meets night, could serve as a temperate sweet spot for habitability. Water is the cornerstone of life as we know it, and TRAPPIST-1 holds promise in this regard. The habitable zone placement implies that, under the right atmospheric conditions, liquid water could exist on its surface. Spectroscopic analyses conducted with the JWST aim to detect water vapor signatures, which would dramatically enhance the planet's appeal as a life-friendly world. The possibility of subsurface oceans, similar to those on Europa or Enceladus in our own solar system, cannot be ruled out. If TRAPPIST-1 harbors underground water reservoirs, they may be shielded from stellar radiation, offering a haven for microbial life. Researchers are also investigating whether volcanic activity or hydrothermal vents could provide the necessary energy to sustain life forms. Despite its many alluring qualities, TRAPPIST-1 faces challenges common to planets orbiting red dwarf stars. Stellar flares and intense radiation bursts from TRAPPIST-1 could strip away planetary atmospheres over time. However, if TRAPPIST-1's magnetic field is robust, it might shield the planet from these destructive forces, preserving its atmosphere and habitability. Moreover, the long lifespans of red dwarf stars offer an advantage. While our Sun has a lifespan of roughly 10 billion years, red dwarfs like TRAPPIST-1 can burn for trillions of years. This extended stability provides ample time for life to emerge and evolve, assuming other conditions are met. The exploration of TRAPPIST-1 and its sister planets represents a cornerstone of modern exoplanetary science. Missions like the JWST and future observatories, such as the Extremely Large Telescope, ELT, are poised to unlock the secrets of this extraordinary system. By analyzing starlight as it passes through TRAPPIST-1's atmosphere, scientists hope to identify chemical fingerprints that could point to biological activity. In addition to remote observations, visionary proposals for interstellar probes could one day bring humanity closer to TRAPPIST-1. Concepts like Breakthrough Starshot aim to propel spacecraft to nearby star systems within a few decades. While such missions remain in their infancy, they highlight the growing ambition to directly study worlds like TRAPPIST-1. The quest to understand whether we are alone in the universe hinges on planets like TRAPPIST-1. As an Earth-like world in a relatively nearby system, it provides an unparalleled opportunity to test hypotheses about life's universality. If signs of life are detected, it would revolutionize our understanding of biology and the cosmos. Conversely, if TRAPPIST-1 proves lifeless despite its favorable conditions, it may underscore the uniqueness of Earth's biosphere. Such findings would carry profound philosophical and scientific implications, reshaping our perspective on the fragility and rarity of life. This enigmatic exoplanet, often referred to as the Second Earth, stands as a beacon of possibility in the vastness of space. Orbiting its dim star within the habitable zone, the world, sometimes called the Twilight Planet due to its tidally locked nature, beckons scientists with its tantalizing promise of alien environments. The study of this celestial neighbor has revealed a planet that defies simple categorization, blending characteristics of terrestrial worlds with the unique challenges posed by its extreme proximity to a red dwarf. The shadowed half of this distant globe, bathed in perpetual night, may hold vast reserves of frozen water, locked away beneath icy crusts. Meanwhile, the sunlit hemisphere endures the unyielding radiation of its faint but volatile parent star. Yet, it is the terminator region, a thin band where light and darkness meet, that has captured the imagination of astrobiologists. Here, conditions may be just right for the formation of liquid water, a critical ingredient for the emergence of life. This so-called golden crescent represents a fascinating test case for planetary habitability beyond Earth. The star system, hosting this extraordinary sphere of rock and possibility, challenges our understanding of planetary formation and survival. In contrast to our solar system, where gas giants like Jupiter act as shields against incoming debris, the worlds orbiting this red dwarf lack such massive protectors. And yet, the exoplanet of Twilight appears remarkably stable, defying expectations of chaotic bombardment. This stability raises questions about the early history of its formation and the role of interstellar forces in shaping its destiny. Further study of this stellar sibling has revealed its remarkable density, suggesting a planet rich in heavy metals and silicates. Such a composition hints at a geologically active surface, potentially marked by volcanic activity or tectonic shifts. If so, these processes could play a pivotal role in recycling carbon dioxide and other greenhouse gases, creating a self-regulating climate system akin to Earth's. Alternatively, the lack of plate tectonics might result in a static environment, where ancient surface features endure for billions of years. Exploration of this exo-Earth has sparked debates about the role of magnetospheres in sustaining habitability. On our home planet, Earth's magnetic field shields us from harmful solar winds and cosmic radiation, preserving the atmosphere and enabling life to thrive. Scientists hypothesize that this alien world may possess a similar magnetic shield, generated by a molten iron core. If true, it would bolster hopes for the long-term stability of its climate and atmospheric composition. Without such a shield, however, the relentless stellar flares from its red dwarf star could strip away any protective gases, rendering the eternal dusk planet a barren, airless wasteland. The possibility of microbial life on this rocky orb ignites fierce curiosity. Could extremophiles, microorganisms capable of thriving in extreme conditions, find a foothold in the planet's more temperate regions? If so, they might exist in forms entirely alien to us, adapting to a world of stark contrasts and perpetual extremes. The discovery of even the simplest life forms here would profoundly alter our understanding of biology and the adaptability of living systems. Astronomers continue to refine their models of the Earth analog, using state-of-the-art telescopes to analyze its atmospheric composition. With the advent of instruments like the James Webb Space Telescope, scientists hope to detect biosignatures, subtle chemical imprints of life. The presence of gases such as oxygen, methane, or ozone in its atmosphere would be a groundbreaking discovery, pointing to the possibility of biological activity. Conversely, a barren atmosphere dominated by carbon dioxide or nitrogen could imply a lifeless world, reminding us of the fragility of life in the cosmos. This alien cousin of Earth also serves as a proving ground for interstellar exploration. While current technology limits us to remote observations, visionary projects like Breakthrough Starshot hint at a future where humanity might send robotic emissaries to nearby star systems. Tiny spacecraft propelled by powerful lasers could reach this distant world within decades, transmitting high-resolution data back to Earth. Such missions would mark the dawn of interstellar exploration, transforming the distant neighbor from a point of light in the night sky to a well-documented world. The cultural implications of the shadowed twin extend beyond science. Its discovery has inspired artists, writers, and dreamers to reimagine humanity's place in the universe. Depictions of its rugged landscapes, illuminated by the eerie glow of its red dwarf star, evoke a sense of wonder and longing. Could this distant planet serve as a refuge for future generations? Or is it a reminder of the uniqueness of Earth, a fragile oasis in an otherwise inhospitable cosmos? The mysteries of this stellar counterpart remain vast, and each new observation adds a piece to the puzzle. Researchers are particularly intrigued by the possibility of organic molecules forming on its surface or in its atmosphere. Such compounds, the building blocks of life, could provide crucial insights into prebiotic chemistry and the conditions necessary for life to emerge. If the pale wanderer proves hospitable to even the simplest organisms, it would redefine the boundaries of habitability and expand our understanding of life's potential in the universe. As technology advances, the study of this exosibling continues to evolve. Missions planned for the coming decades will employ advanced spectrometers, capable of analyzing the light reflected and absorbed by its surface. These observations will help determine the composition of its soil, the presence of minerals, and even the likelihood of liquid water. With each new discovery, the rocky enigma becomes less of a distant dream and more of a tangible reality, drawing us closer to answering the age-old question, are we alone? The cosmic twin of Earth continues to captivate scientists with its intricate dance around its dim star. Orbiting at a distance that perfectly balances energy and temperature, this exoplanet, often described as the Crimson Haven, embodies the delicate equilibrium necessary for life. Its close orbit around its red dwarf sun exposes it to a slow, rhythmic stellar cycle that profoundly impacts its climate and atmospheric dynamics. The perpetual day side of this tidal orb basks in the steady but subdued glow of its parent star, creating a stark contrast to the frigid night side. The boundary between these extremes, the twilight zone, could act as a crucible for complex atmospheric circulation. Winds might carry heat from the illuminated hemisphere to the frozen regions, creating conditions for water to exist in liquid form at the planet's surface or even beneath its crust. Advanced climate modeling has revealed fascinating possibilities: polar ice caps extending into the night side, massive cloud formations on the day side, and constant storms in the transition zones. This eternal twilight planet poses questions that reach beyond habitability into the realms of planetary evolution. The tidal locking it experiences is not unique, many exoplanets close to their stars share this characteristic. Yet, TRAPPIST-1e, or the dusklit world, stands apart for its ability to potentially sustain life despite this constraint. The energy balance between the hemispheres could be moderated by atmospheric composition, with greenhouse gases like carbon dioxide or methane acting as insulators. If these gases are present in just the right proportions, the planet could maintain a stable climate over millions of years. In recent studies, astronomers have focused on the possibility of a dense, oxygen-rich atmosphere on this starlight sibling. While oxygen is often associated with biological processes, it could also result from abiotic mechanisms, such as the photodissociation of water molecules under intense stellar radiation. The existence of oxygen without accompanying methane or other biosignatures would complicate the search for life, challenging scientists to distinguish between chemical processes that mimic biological activity and those that genuinely signal life's presence. The planetary surface of this cosmic mystery is equally intriguing. If volcanic activity is ongoing, it could contribute to the replenishment of atmospheric gases while creating geothermal pockets of habitability. Hydrothermal vents, similar to those found in Earth's oceans, could provide energy sources for microbial ecosystems. These vent systems, shielded from the harsh radiation of the star, might host unique life forms that thrive in extreme environments. The very thought of alien microbes surviving under such conditions fuels the search for similar systems on other rocky worlds across the galaxy. The shadowed Earth, as some researchers call it, also offers an unparalleled opportunity to study the long-term effects of stellar radiation on planetary atmospheres. Red dwarfs, while long-lived, are notorious for their flaring activity. During these solar events, bursts of charged particles could erode a planet's atmosphere over time. Yet, TRAPPIST-1 appears to defy this trend, possibly due to a strong magnetic field generated by a liquid metallic core. This protective barrier could act as a shield, preserving the planet's habitability even in the face of constant stellar bombardment. For scientists, the alien mirror serves as a reminder of how interconnected planetary systems are. The interplay between its surface, atmosphere, and magnetic field mirrors the dynamics observed on Earth, albeit under vastly different conditions. This makes the extraterrestrial twin an ideal testbed for developing and refining models of planetary evolution, habitability, and climate science. Each observation adds a new layer of complexity to our understanding, challenging existing theories and inspiring innovative approaches. The future of research into this habitable paradox lies in the hands of next-generation observatories. The James Webb Space Telescope has already begun unlocking the secrets of its atmosphere, but even more powerful instruments, such as the upcoming LUVOIR, Large UV/Optical/IR Surveyor, promise to take the search for life to unprecedented levels. These telescopes will analyze the starlight passing through the exoplanet's atmosphere during transits, identifying chemical signatures that could point to biological activity. With each new dataset, the reddish pearl transforms from an abstract concept into a tangible world rich with scientific potential. The allure of this distant sibling extends beyond the scientific community. For philosophers, its existence forces humanity to grapple with existential questions about our place in the universe. If the Crimson Echo harbors life, it would mean that the processes leading to biology are not unique to Earth but are a natural outcome of planetary evolution under the right conditions. Conversely, if the planet is barren despite its promising characteristics, it might underscore the rarity and fragility of life as we know it. Explorers and engineers dream of the day when humanity might send robotic emissaries, or even crewed missions, to this stellar cousin. The development of advanced propulsion systems, capable of reaching nearby star systems within a human lifetime, remains a long-term goal. Concepts like fusion-powered spacecraft or laser sails could turn the dream of visiting this rocky enigma into reality. Until then, scientists must rely on remote sensing and theoretical models to decode its mysteries. This twilight orb stands as a beacon of hope and wonder in the vastness of space. Each new discovery brings humanity closer to understanding the conditions necessary for life, not just on TRAPPIST-1 but throughout the cosmos. The study of this remarkable exoplanet serves as a bridge between science and imagination, inspiring future generations to look up at the night sky and dream of worlds yet unseen. This distant wonder, often dubbed the alien Eden, continues to redefine humanity's understanding of what it means to be habitable. Orbiting its ancient red dwarf star with such precision, the exoplanet dances in a gravitational harmony that defies the chaotic beginnings of its system. While TRAPPIST-1 and its sister planets exist in extreme proximity to their Sun, the stability of their orbits over billions of years suggests that these worlds may have weathered the violent youth of their star, an achievement that lends further credence to the possibility of their survival as bastions of habitability. Scientists hypothesize that the planet's slow rotation, locked into tidal equilibrium, creates dynamic and turbulent atmospheric conditions. The ever-present heat on its day side may generate rising currents of air that travel toward the cold night side, cooling and condensing into massive, sprawling cloud systems. These clouds, in turn, reflect some of the incoming radiation from the red dwarf star, preventing runaway heating. Meanwhile, the frigid night side might act as a heat sink, fostering a bizarre, planet-wide exchange of energy that may sustain a globally balanced climate. The twilight frontier, as some researchers call it, is where life could flourish. This narrow, crescent-shaped region is bathed in soft, eternal dusk, with temperatures potentially hovering near Earth-like levels. Here, liquid water could exist on the surface, forming rivers, lakes, or even shallow seas. If this ribbon of twilight hosts an atmosphere thick enough to distribute warmth evenly, it might serve as an ecological oasis, teeming with microbial life forms that thrive in the delicate balance between light and dark. The geological activity of this shadowed gem remains one of the most compelling areas of research. Recent models suggest that internal heating, caused by tidal interactions with neighboring planets, could drive volcanic eruptions or even tectonic movement. Such activity would play a crucial role in maintaining the planet's atmosphere, replenishing it with vital gases while creating diverse habitats for potential life. Volcanism might also release water vapor, which, if it condenses into rain, could carve intricate landscapes of valleys and deltas, painting the surface with geological features that mirror Earth's dynamic history. As this exoplanetary sibling continues to be studied, the question of its magnetic field has become a focal point. A robust magnetic field would not only shield the planet from harmful radiation but also preserve its atmosphere against the powerful stellar winds of its red dwarf host. Without such a protective field, the planet's surface could be exposed to intense bursts of radiation during stellar flares, dramatically reducing its chances of sustaining life. Yet, even in this scenario, life might adapt by retreating underground or beneath protective layers of ice. The cosmic mirror holds a particular fascination for astrobiologists, who view it as a laboratory for testing theories about the universality of life. If the planet contains liquid water and the right chemical building blocks, life could have emerged independently, following paths. This alien sanctuary, often referred to as the stellar twin, continues to captivate the scientific imagination. Orbiting its faint red star in a delicate gravitational balance, this remarkable world stands as a testament to the possibilities of life beyond our solar system. The Crimson Voyager, with its potential for hosting Earth-like conditions, challenges our understanding of planetary resilience and adaptability in extreme environments. The exocousin of Earth, locked in eternal rotation with one side facing perpetual light and the other eternal darkness, creates a unique dynamic of contrasts. Its day side, bathed in the soft red glow of its star, could be a land of scorching heat and towering clouds. The night side, frozen and silent, might be home to ice sheets or subsurface water reservoirs. Between these extremes lies the habitable band, a narrow twilight region where temperatures and conditions could align perfectly for the presence of liquid water, a prerequisite for life as we know it. The rocky wanderer, much like Earth, shows evidence of being composed largely of silicate materials and heavy elements. These properties suggest that it could harbor a solid surface, one potentially marked by a diverse landscape of plains, mountains, and perhaps ancient volcanic remnants. Scientists speculate that geothermal activity beneath the crust of this stellar sibling could create energy sources similar to Earth's hydrothermal vents, which are known to support thriving ecosystems deep in our oceans. One of the most intriguing possibilities for the shadowed orb is its atmosphere. Preliminary studies suggest the potential for a thick layer of gases that could act as a buffer against the star's radiation. If such an atmosphere exists, it might contain water vapor, carbon dioxide, and other compounds that not only sustain a stable climate but also provide essential ingredients for life. The presence of biosignatures, such as oxygen or methane, would transform the extraterrestrial Eden from a scientific curiosity into a revolutionary discovery. The twilight gem is not without its challenges. Its proximity to a red dwarf star subjects it to frequent stellar flares, which could strip away its atmosphere if unprotected. However, the existence of a magnetic field could mitigate these effects, shielding the celestial neighbor from harmful solar winds and maintaining its atmospheric integrity. This protective feature, if confirmed, would greatly enhance the planet's potential to host life, making it one of the most promising candidates in the search for habitable worlds. The dusk-lit enigma has also reignited discussions about interstellar exploration. Advanced telescopes like the James Webb Space Telescope are already unlocking new details about its atmospheric composition, but the dream of visiting this distant world remains alive. Concepts such as laser-propelled probes or fusion-powered spacecraft aim to bring humanity closer to the cosmic frontier, allowing us to directly study its surface and perhaps even sample its environment for signs of life. The pale Voyager is more than a distant dot of light in the sky, it represents the hopes and dreams of a species yearning to understand its place in the cosmos. Whether it is teeming with microbial ecosystems or a barren rock, the discoveries awaiting on this stellar kin will undoubtedly reshape our perspective on life's potential across the galaxy. This crimson refuge, orbiting its faint, ancient star, remains one of the most captivating enigmas of modern astronomy. Often called the exoplanetary sibling, it represents an extraordinary opportunity to explore the boundaries of planetary habitability. Nestled within its host star's habitable zone, the eternal twilight sphere offers a tantalizing glimpse into what might be a second home for life in the universe. The distant cousin of Earth exhibits a range of extraordinary features. Its tightly locked orbit creates a permanent divide between the searing day side and the frigid night side, forming a stark dichotomy across its surface. The transition zone between these extremes, often referred to as the life belt, may hold the key to understanding how life could adapt to such unique conditions. Here, temperatures are believed to hover at levels conducive to liquid water, the fundamental ingredient for life as we know it. The celestial wanderer has inspired countless theories about its atmospheric composition. Researchers hypothesize that this reddish sibling might host a thick layer of gases that moderates the temperature contrasts between its hemispheres. This atmosphere could act as a natural thermal blanket, circulating heat and creating a relatively stable environment in the twilight regions. Advanced spectroscopic studies are already underway to detect key atmospheric components such as water vapor, carbon dioxide, and oxygen, each of which could provide vital clues about the planet's habitability. The star-bound neighbor has also raised intriguing possibilities about its hydrological systems. If liquid water exists, it may form narrow rivers or shallow oceans along the planet's terminator line. Alternatively, water might be locked away as ice on the night side, periodically released through geothermal activity or subsurface heating. This shadowed oasis could serve as a breeding ground for extremophile-like organisms, adapted to thrive in conditions far harsher than those on Earth. Geological activity on the alien sibling is another avenue of intense exploration. Internal heating from tidal interactions with its neighboring planets in the TRAPPIST-1 system might drive volcanism and tectonic activity, creating a dynamic and ever-changing surface. These processes could replenish atmospheric gases and maintain long-term climate stability, critical for sustaining life. Furthermore, volcanic regions on this exotwin might host geothermal hotspots, fostering the kinds of ecosystems seen around Earth's hydrothermal vents, places where life thrives in complete isolation from sunlight. The tidally locked mystery also challenges scientists with the unique effects of its host star's red dwarf nature. These stars are known for their volatility, emitting powerful stellar flares that could erode a planet's atmosphere over time. Yet the Crimson Enigma appears to have defied this fate, likely due to its potential magnetic field. If this shield exists, it would be a vital factor in protecting the planet's atmosphere and preserving the conditions necessary for life. The dusklit pearl also represents a critical milestone for interstellar exploration. Observations of this world are paving the way for more advanced missions and instruments capable of probing its secrets in unprecedented detail. Future telescopes, such as the Extremely Large Telescope, ELT, and LUVOIR, aim to unlock even more insights into its composition, climate, and potential biosignatures. Meanwhile, visionary projects like Breakthrough Starshot dream of one day sending probes to the stellar cousin, capturing images and data from its surface within a human lifetime. The twilight orb, while still shrouded in mystery, serves as a reminder of the vast possibilities that lie beyond our solar system. Its discovery has reignited humanity's fascination with the cosmos, inspiring a new generation of explorers, scientists, and dreamers to imagine what life might look like on a world so similar yet so alien to our own. If this far-off Earth analog harbors life, it could provide answers to one of the greatest questions of all: are we alone in the universe? Even if the shadowed world proves barren, its study will teach us invaluable lessons about planetary evolution, climate dynamics, and the resilience of worlds orbiting volatile red dwarf stars. Each observation and model refines our understanding, bringing us closer to uncovering the truths hidden within the light of its distant star. The exoplanetary marvel challenges not just our scientific knowledge but also our philosophical perspectives. If it hosts life, it will reveal that biology is not unique to Earth but an intrinsic part of the universe. If it does not, it will remind us of the rarity and preciousness of our fragile blue world. Either way, the alien mirror has become an irreplaceable part of humanity's search for meaning among the stars. The crimson reflection, as some call it, is not merely an object of study, it has become a symbol of the unyielding human drive to understand the cosmos. TRAPPIST-1e, this stellar anomaly, exists as a puzzle piece in the broader tapestry of exoplanetary science, and every observation draws us closer to unraveling its secrets. Its allure lies not only in its potential to host life but in the profound questions it raises about the diversity of planetary systems and their capacity to nurture biology. The Twilight Voyager, locked in a gravitational embrace with its dim parent star, may hold answers about the adaptability of life under conditions vastly different from those on Earth. While the harsh radiation from its volatile red dwarf might seem hostile to life, some researchers argue that such conditions could drive evolution in unexpected ways. Lifeforms, if they exist on this distant echo of Earth, might have developed biochemical pathways to shield themselves from ultraviolet radiation or utilize the dim, reddish light for energy in ways we have yet to imagine. Atmospheric studies of the celestial sibling have revealed intriguing possibilities. If clouds of reflective particles exist on its day side, they could scatter incoming stellar radiation, preventing the planet from overheating. Conversely, a thicker atmosphere on the night side could act as insulation, trapping heat and maintaining a stable temperature gradient. This balance, if present, might create microclimates where complex ecosystems could thrive. The Terminator line, a perpetual band of twilight, represents the most likely candidate for such regions, a place where liquid water could pool and nutrients might circulate. Beyond its physical characteristics, the exo-Earth also offers an unparalleled opportunity to refine our methods for detecting life on distant worlds. Current efforts to analyze its atmosphere using the James Webb Space Telescope have focused on identifying specific molecules like oxygen, ozone, methane, and water vapor. The detection of these gases in the right proportions would strongly suggest biological processes. However, even the absence of such biosignatures could be valuable, pushing scientists to reevaluate what habitable truly means in the context of alien worlds. The reddish twin also serves as a natural experiment in planetary geology. Its rocky composition, combined with the intense gravitational interactions of its neighboring planets, suggests a dynamic interior. These tidal forces may generate enough internal heat to sustain volcanic activity, which could in turn support a cycling of elements between the surface and the atmosphere. Such activity, crucial for maintaining habitability over long timescales, might also create striking geological features, towering volcanoes, expansive lava plains, or deep fissures carved by tectonic shifts. The tidally bound sphere is not alone in its system, and the interplay between it and its neighboring planets offers valuable insights into multiplanetary systems. The TRAPPIST-1 system, with its 7 tightly packed worlds, is a rare opportunity to study how planetary environments evolve in close proximity to one another. The gravitational tug-of-war among these planets creates orbital resonances that stabilize their orbits, a phenomenon that might also influence their climates and potential habitability. This symphony of worlds is a cosmic dance that has persisted for billions of years, a testament to the delicate balances that nature can achieve. As humanity's technological capabilities grow, so too does the ambition to explore the alien sanctuary in greater detail. Future telescopes, both space-based and ground-based, will provide unprecedented resolution, allowing scientists to map surface features, track atmospheric changes, and perhaps even detect signs of vegetation or other large-scale biological processes. Missions like LUVOIR or HABEX could one day capture direct images of this cosmic counterpart, revealing it as more than just a point of light, a fully realized world with its own landscapes and weather systems. The twilight orb is also a source of inspiration for interstellar exploration. Concepts for reaching nearby star systems, such as Breakthrough Starshot's laser-driven probes, are already in development. These microspacecraft, capable of traveling at a significant fraction of the speed of light, could reach the TRAPPIST-1 system within a few decades, providing humanity with its first close-up view of an exoplanetary system. Such missions, though still in their infancy, highlight the growing convergence of science and engineering in the quest to explore the stars. The cultural impact of the stellar twin cannot be overstated. Its discovery has sparked a renaissance of creativity, inspiring art, literature, and philosophy that explore the implications of finding another Earth-like world. For some, the dusk-lit marvel represents hope, a vision of humanity's future among the stars. For others, it serves as a humbling reminder of Earth's uniqueness and the fragility of life in an often hostile universe. The study of this distant neighbor has profound implications for our understanding of life's potential in the cosmos. If life is found on this crimson refuge, it will confirm that biology is not a cosmic anomaly but a natural outcome of the universe's processes. If no signs of life are detected, it will sharpen our focus on the conditions that make Earth so uniquely suited for life. In either case, the exo-Earth stands as a symbol of humanity's relentless curiosity and determination to seek answers to the most profound questions. The exploration of this cosmic enigma is far from over. As each new instrument and mission brings us closer to unraveling its mysteries, the alien cousin will continue to inspire awe, challenge assumptions, and expand the boundaries of human knowledge. It is not merely a planet, it is a gateway to understanding our place in the universe and the possibilities that lie beyond. The stellar echo reminds us that the cosmos is vast, filled with worlds waiting to be explored, each one holding the potential to transform our understanding of existence itself. The crimson outlier, still shrouded in mystery, remains a focal point of scientific intrigue and speculation. Every detail we uncover about this remarkable world strengthens its position as a prime candidate for hosting life. Its placement within the habitable zone of its dim red star, a region often referred to as the Goldilocks zone, is only the beginning of the story. The stellar parallel offers far more than just favorable temperatures, it provides a glimpse into how life might emerge and evolve under entirely different cosmic circumstances. The eternal twilight sphere, with its tidally locked orbit, poses unique challenges for habitability. Unlike Earth, where the rotation creates dynamic day-night cycles, this alien world experiences an unchanging dichotomy. The day side, constantly bathed in the faint red glow of its star, might develop thick, heat-reflecting cloud layers to moderate surface temperatures. The night side, in perpetual darkness, could accumulate vast ice sheets, creating a frozen realm that contrasts starkly with the scorching heat of the day. Between these extremes, the life band, the narrow zone of perpetual dusk, offers a promising sanctuary where temperatures may remain mild enough to sustain liquid water. The possibility of water, either on the surface or locked within subsurface reservoirs, is central to the planet's allure. If liquid water exists, it could flow through the twilight zone in narrow rivers or pool into shallow lakes, creating environments rich in the potential for microbial life. The reddish twin may also harbor vast oceans beneath a thick ice crust on its dark side, similar to Europa or Enceladus in our solar system. Such subsurface oceans, warmed by geothermal activity, could provide a stable and long-lasting refuge for life, protected from the harsh radiation of its volatile red dwarf star. Astrobiologists studying the exo-Earth are particularly interested in its atmospheric composition. If the atmosphere contains greenhouse gases like carbon dioxide, methane, or even water vapor, it could trap heat efficiently, smoothing out the extreme temperature differences across the planet. Additionally, the presence of oxygen, though not necessarily a direct indicator of life, would suggest intriguing chemical processes at work. Future observations using advanced telescopes aim to probe deeper into these possibilities, searching for the subtle chemical fingerprints that might reveal whether this alien haven harbors life. The shadowed cousin also raises questions about planetary geology. Its density suggests a rocky composition, with a core rich in heavy metals and a crust capable of sustaining tectonic activity. Volcanism on the planet's surface could play a key role in recycling essential elements and releasing gases into the atmosphere, a process that might sustain a stable climate over millions of years. If hydrothermal vents exist beneath its surface, they could provide localized energy sources, fostering unique ecosystems similar to those found in Earth's deep oceans. The dusklit anomaly is not just an isolated object of fascination, it is part of a larger family of 7 planets in the TRAPPIST-1 system. These worlds, all tightly packed around their star, interact gravitationally in a delicate orbital resonance. This planetary symphony not only stabilizes their orbits but may also influence their climates and geological activity. The interactions among these worlds offer a rare opportunity to study the dynamics of compact planetary systems, shedding light on how such configurations evolve and persist over billions of years. One of the most compelling aspects of the stellar mirror is the potential impact of its parent star on its habitability. Red dwarfs, though long-lived, are known for their volatile behavior, emitting powerful flares that could strip away planetary atmospheres over time. However, the Crimson Sanctuary appears to defy this threat, potentially protected by a magnetic field that shields it from stellar radiation. If this is the case, it would mark a significant milestone in our understanding of how planets in such extreme environments can sustain life-friendly conditions. The tidal enigma has also become a testbed for cutting-edge technologies designed to explore distant worlds. Instruments like the James Webb Space Telescope are already providing unprecedented insights into its atmosphere, while future observatories, such as the Habitable Worlds Observatory, promise even greater discoveries. These tools are capable of detecting faint signals that could point to the presence of life, such as variations in atmospheric composition over time or even seasonal changes indicative of biological processes. The exosibling also fuels humanity's aspirations for interstellar exploration. Projects like Breakthrough Starshot envision sending tiny, high-speed probes to nearby star systems, including the TRAPPIST-1 system, to capture close-up images and data. Such missions, while decades away, represent the next great leap in humanity's quest to reach out into the cosmos. The Twilight Voyager stands as a symbol of what might be achievable, a distant goal that inspires engineers, scientists, and dreamers alike. Philosophically, the alien echo forces us to confront profound questions about our place in the universe. If life exists on this distant world, it would confirm that the processes leading to biology are not unique to Earth but a natural outcome of the cosmos. Such a discovery would reshape not only science but also humanity's sense of identity, proving that we are part of a larger, interconnected web of life spread across the galaxy. On the other hand, if the shadowed wonder proves barren, it would highlight the extraordinary rarity of life, underscoring the importance of preserving our fragile planet. The exploration of this crimson frontier is far from over. Each new observation peels back another layer of mystery, revealing a world that is at once familiar and alien. Whether it ultimately proves to be a cradle of life or a barren rock, the stellar cousin will forever remain a testament to humanity's insatiable curiosity and our enduring desire to understand the universe. This cosmic sibling, with its quiet orbit around a faint, ancient star, reminds us that even in the vast emptiness of space, there are places where life might yet bloom, waiting to be discovered. The reddish sanctuary, a beacon of scientific hope, continues to drive humanity's greatest questions about life and the universe. As scientists push the boundaries of technology and theory, the mysteries of this exo-Earth become clearer, yet simultaneously deeper. This alien world, orbiting quietly within its compact planetary system, acts as a natural laboratory for exploring everything from planetary geology to astrobiology to interstellar dynamics. The dusklit enigma is no longer just a point of light in the sky, it is a gateway to understanding life's potential across the cosmos. The tidal marvel, locked in gravitational stasis with one side eternally basking in light and the other forever cast in shadow, likely harbors an extraordinary range of environments. The Terminator Zone, where day meets night, remains the prime focus of habitability studies. This narrow band of twilight could harbor mild temperatures, liquid water, and even active weather systems. Winds from the day side may carry heat and moisture into the cooler regions, creating a cycle of precipitation and evaporation that sustains complex ecosystems, if life exists. However, the Crimson Twin does not make survival easy. The red dwarf star it orbits emits frequent solar flares, bursts of radiation that could wreak havoc on the planet's atmosphere. But there is evidence that this stellar echo might have a natural defense, a magnetic field. Generated by a molten core deep within its interior, this field could act as a shield, protecting its atmosphere from being stripped away and allowing it to sustain a stable climate over billions of years. Such a magnetic field would also open the door to possibilities for life on the surface, as it could block harmful cosmic rays while allowing essential light and heat to reach the planet. The shadowed oasis is not just a scientific curiosity, it is also a place of profound geological interest. Its density and composition suggest a rocky world similar to Earth, yet unique in its formation and evolution. Gravitational interactions with its neighboring planets in the TRAPPIST-1 system generate tidal heating, which may drive volcanic activity beneath its surface. These volcanic processes could release gases like carbon dioxide, replenishing the atmosphere and creating localized hotspots where life might flourish. If tectonic activity exists, it could further diversify the planet's surface, forming mountains, valleys, and deep ocean basins that could act as reservoirs for liquid water. The exosibling also challenges scientists to rethink their assumptions about habitability. While Earth-like conditions are often seen as the gold standard, the Twilight Refuge may demonstrate that life can arise and thrive under entirely different circumstances. In its dim, reddish environment, life forms might rely on alternative biochemical processes, perhaps utilizing the faint infrared light from its star as an energy source. Microbial life, if present, could be adapted to extreme radiation, high levels of carbon dioxide, or even long periods of environmental stability punctuated by bursts of activity during stellar flares. One of the most exciting aspects of the alien haven is its potential to host water in multiple forms. While liquid water on the surface remains the holy grail of astrobiology, the possibility of vast underground oceans is equally intriguing. Subsurface water could remain liquid due to geothermal heating, creating a stable, long-term habitat for life. If this cosmic cradle hosts hydrothermal vents, it might mirror the conditions thought to have given rise to life on Earth, offering a glimpse into how biology could begin elsewhere in the universe. The reddish enigma is also a technological proving ground. Instruments like the James Webb Space Telescope are already revolutionizing our ability to study distant worlds, providing detailed analyses of their atmospheres and surface conditions. Spectroscopic observations of this stellar twin have begun to reveal its atmospheric structure, with the hope of detecting biosignatures such as oxygen, methane, or even ozone. Future missions, like the LUVOIR or HABEX telescopes, will be capable of directly imaging the planet, potentially capturing the first clear view of an Earth-like world beyond our solar system. The Twilight Voyager inspires not only scientists but also engineers and futurists. Concepts for interstellar travel, such as laser-driven light sails or fusion-powered spacecraft, are being developed with planets like this in mind. A probe sent to the TRAPPIST-1 system could provide humanity with its first close-up data on an exoplanetary system, revolutionizing our understanding of the universe. Such missions, though decades or even centuries away, represent the next frontier of exploration, and the Crimson Sibling serves as a shining beacon for what might one day be achievable. Culturally, the distant cousin has sparked a renaissance in art, literature, and philosophy. Its discovery has inspired countless works of fiction, imagining what life might look like on a tidally locked world, where the sun never rises or sets. Philosophers have pondered the implications of finding life, or not finding it, on such a world. Would it prove that life is common, or would it remind us of how uniquely precious Earth is? Either way, the alien mirror forces humanity to reflect on its place in the cosmos, encouraging a broader perspective on the fragility and resilience of life. The exotwin, whether teeming with microbial life or barren and rocky, offers profound lessons about the nature of existence. If life is found on this stellar echo, it would suggest that biology is a universal phenomenon, emerging wherever conditions allow. Conversely, if the planet is lifeless despite its promising characteristics, it would underscore the rarity of Earth and the delicate balance required to sustain life. Ultimately, the Crimson Refuge represents humanity's enduring quest to explore, understand, and connect with the universe. Each new discovery brings us closer to answering the age-old question, are we alone? The dusk-lit marvel, orbiting its faint star in a quiet corner of the galaxy, reminds us that even in the vast emptiness of space, there are worlds waiting to be uncovered, worlds that may one day redefine what it means to be human. The Crimson Cradle, endlessly orbiting its faint red star, symbolizes humanity's most profound questions about the cosmos. With every passing year, this stellar counterpart grows less mysterious yet increasingly fascinating. As more data trickles in from advanced telescopes and missions, this twilight enigma becomes a mosaic of possibilities, a world that offers both tantalizing clues and infinite questions about the nature of life and planetary evolution. The alien beacon, forever caught in a gravitational lock with its host star, has long been the subject of climate modeling and speculation. Unlike Earth, where global weather systems are driven by the rotation of the planet, this dusk-lit sphere presents a more static yet equally complex challenge. Scientists believe that winds on the planet may move heat and moisture from its sunlit side to the dark hemisphere, creating immense cyclonic systems and atmospheric jets that encircle the twilight zone. This dynamic, known as atmospheric redistribution, could make the golden crescent of habitability wider than initially believed, providing an even greater chance for liquid water and life to thrive. What truly sets the shadowed sibling apart is its position within the TRAPPIST-1 system, a compact arrangement of 7 Earth-sized planets. Each of these worlds orbits its ultra-cool red dwarf star closer than Mercury does to the Sun, yet their unique gravitational resonance stabilizes the system over billions of years. This resonance also contributes to the tidal forces acting on the reddish anomaly, generating internal heat that might fuel volcanic activity or subsurface oceans. The delicate gravitational dance among these planets paints a picture of a system in harmony, each world influencing the others in ways that scientists are only beginning to understand. On the surface of the exocosm, the conditions might be far stranger than anything found on Earth. Imagine a landscape where the day side glows under a dim, eternal red light, its ground cracked and baked by the stars' constant gaze. Meanwhile, the night side would stretch into infinite darkness, a frozen wasteland where temperatures could plummet to hundreds of degrees below zero. Yet, along the terminator line, where day and night meet, there might be a zone of relative tranquility, a place of perpetual dawn or dusk, where temperatures hover around the melting point of water. Here, life might find its foothold, thriving in pools of liquid water or beneath protective layers of soil. If life exists on the crimson sphere, it might look nothing like what we see on Earth. Under the dim red light of its star, photosynthetic organisms, if they exist, would need to adapt to the infrared spectrum, possibly appearing black or dark gray to maximize energy absorption. Alternatively, life could exist underground, shielded from radiation and thriving near geothermal vents or within mineral-rich water reservoirs. Microbial life, similar to extremophiles on Earth, could be perfectly adapted to these harsh and alien conditions, surviving in environments that would be lethal to most terrestrial organisms. The stellar neighbor is also a treasure trove for planetary chemistry. Its atmosphere, if it exists, holds the key to understanding its potential for life. Scientists are searching for biosignatures, gases like oxygen, methane, or nitrous oxide, that would indicate biological processes. However, even the absence of such gases could reveal crucial information about its history, geology, and interactions with its parent star. The twilight enigma is not just a candidate for life but a window into the diversity of planetary atmospheres, helping us refine our search for habitable worlds across the galaxy. The tidal wonder poses a fascinating conundrum about water. While liquid water on its surface would be the most direct indicator of habitability, the possibility of subsurface oceans cannot be ignored. On Earth, similar oceans beneath the icy crusts of Europa and Enceladus teem with the chemical ingredients necessary for life. The exo-Earth might harbor vast reservoirs of water beneath its rocky surface, kept liquid by tidal and geothermal heating. These hidden oceans, if they exist, could serve as cradles for alien ecosystems, protected from the harsh radiation of its red dwarf star. From a technological standpoint, the reddish mirror represents an extraordinary challenge. Observing a planet so distant and faint requires instruments of unparalleled precision. The James Webb Space Telescope has already begun to reveal the first glimpses of its atmosphere, but the next generation of observatories promises even more. Missions like the Extremely Large Telescope (ELT) and the Habitable Worlds Observatory will bring humanity closer to answering the ultimate question: is this crimson world a home for life? Philosophically, the alien twin forces us to confront our assumptions about what it means to be alive and what constitutes a habitable planet. If this world, with its extreme conditions and faint sunlight, can sustain life, it would redefine our understanding of biology and resilience. Conversely, if it is barren despite its favorable characteristics, it might suggest that life is far rarer than we currently believe. Either way, the shadowed pearl serves as a mirror for humanity, reflecting both our hopes and our limitations in the search for meaning in the universe. The exosibling is more than just a scientific target, it is a symbol of exploration and ambition. Its discovery has already reshaped our understanding of planetary systems, proving that Earth-like worlds can exist in a wide variety of environments. As humanity continues its quest to study the Crimson Beacon, we are reminded of the vast potential of the cosmos, the endless possibilities waiting just beyond our reach. This twilight sanctuary, perched on the edge of possibility, represents the frontier of human knowledge. Whether it harbors life or stands as a monument to cosmic isolation, the stellar echo will forever remain a testament to humanity's unyielding desire to explore, to question, and to dream. The Crimson Bastion, as it has come to be known among researchers, occupies a unique place in our collective imagination. Orbiting in the tranquil glow of its ancient red dwarf star, this alien ember offers a vision of what could be, a world teetering on the edge of habitability, full of tantalizing potential. With its delicate balance of extremes, searing heat on one side, freezing cold on the other, it symbolizes resilience in the face of cosmic adversity. Yet it also serves as a mirror, reflecting our deepest questions about life, survival, and the fragility of existence. The Twilight Sanctuary is part of a planetary system so densely packed that it challenges conventional wisdom about how planets form and evolve. The TRAPPIST-1 system itself is an anomaly, 7 Earth-sized worlds, tightly clustered around a star so faint and small that it barely qualifies as a star by traditional standards. These planets, including the Dusklit Wonder, are locked in a complex orbital resonance, a celestial dance that ensures their long-term stability. This arrangement defies the chaos typically associated with young planetary systems and raises questions about how such a finely tuned system could emerge. For the tidally frozen sibling, this resonance is not just a stabilizing force but also a source of energy. The gravitational pull of its neighboring planets creates tidal stresses that heat its interior, much like Jupiter's moon Io. This internal furnace could drive volcanic activity on a scale unimaginable on Earth. These volcanoes might spew gases into the atmosphere, replenishing it with carbon dioxide, water vapor, and other essential molecules, sustaining a dynamic climate for billions of years. In this way, the exo-Earth might transform what appears to be a static, barren world into a planet teeming with geological, and perhaps biological, activity. The shadowed twin also provides a rare opportunity to study the interplay between a planet's atmosphere and its host star. Red dwarfs like TRAPPIST-1 are notorious for their flaring activity, emitting bursts of radiation that could strip away a planet's atmosphere over time. Yet, the Crimson Sphere seems to have defied this fate, potentially thanks to a strong magnetic field. If confirmed, this protective field would suggest that even planets orbiting volatile stars can retain their atmospheres and remain habitable, a finding that could dramatically expand the number of worlds considered capable of supporting life. In the eternal twilight zone, where the day side transitions into night, conditions may be just right for life to emerge. Here, temperatures are mild enough to allow liquid water to pool on the surface, while the constant dim light from the star might sustain basic photosynthesis. The chemical interactions in this region could create a complex prebiotic soup, setting the stage for the first self-replicating molecules. If life exists on this alien refuge, it might resemble Earth's extremophiles, organisms that thrive in environments once thought uninhabitable. From radiation-resistant microbes to chemical-eating bacteria, the possibilities for alien life are as varied as the conditions on this cosmic haven. The reddish cradle also inspires speculation about its surface. What would it be like to stand on this alien world? On the day side, one might see a dim, crimson sky dominated by the faint disk of the star, casting long, eerie shadows. The terrain could be rugged and rocky, punctuated by rivers of molten lava or vast plains of hardened basalt. On the night side, the darkness would be absolute, broken only by the faint glow of auroras caused by charged particles interacting with the planet's magnetic field. And along the terminator, where light and dark meet, the view might be otherworldly, a sky that fades from deep black to a dusky red, over landscapes softened by perpetual twilight. The exocompanion is more than just a geological marvel. It is also a testbed for humanity's growing technological prowess. Instruments like the James Webb Space Telescope are already probing its atmosphere for signs of life, searching for gases that could reveal biological activity. These efforts are pushing the boundaries of what is scientifically possible, requiring astronomers to distinguish between natural processes and potential biosignatures. For example, oxygen in the atmosphere might result from water molecules broken apart by stellar radiation rather than photosynthesis. Such findings force researchers to reconsider what signs of life might look like on worlds vastly different from Earth. The twilight gem is also shaping the future of space exploration. Concepts for reaching nearby star systems, such as laser-driven probes, are being designed with planets like this in mind. These tiny spacecraft, traveling at a fraction of the speed of light, could reach the TRAPPIST-1 system in a few decades, sending back invaluable data about the Crimson Haven. Such missions represent humanity's first steps toward interstellar exploration, turning what was once science fiction into tangible goals. Philosophically, the stellar twin is a source of endless fascination. Its existence challenges us to think beyond Earth-centric definitions of life and habitability. If life exists on this dusk-lit sphere, it would force us to confront the idea that biology might be a universal phenomenon, emerging wherever the conditions allow. On the other hand, if it is barren despite its favorable conditions, it would underscore the rarity and preciousness of our own planet, a fragile oasis in a vast and uncaring universe. As humanity continues to study the alien ember, its mysteries become part of our shared story. It is not just a scientific object but a symbol of what we can achieve when curiosity and ambition drive us forward. Whether it is a cradle of life or a barren rock, the reddish sanctuary reminds us of the endless possibilities that lie beyond the boundaries of our solar system. It is a testament to the resilience of worlds, the creativity of science, and the unyielding desire to explore the unknown. The Crimson Frontier, perched in the quiet depths of the TRAPPIST-1 system, continues to capture the imagination of scientists, dreamers, and visionaries alike. This alien threshold is more than a distant planet, it is a symbol of discovery, a testament to the vastness of the universe and the potential for life beyond Earth. As humanity gazes at this dusk-lit sanctuary, it becomes a canvas for understanding how life might arise, evolve, and persist under conditions unlike anything we have known. The stellar sibling, locked in its gravitational embrace with its dim, ancient star, is both a riddle and a revelation. Its perpetual day and night sides create a world of extremes, searing heat and frigid cold separated by the tenuous balance of the twilight zone. Along this eternal dusk belt, where light and darkness meet, lies the greatest hope for habitability. This strip of mild temperatures, stretching across the planet's surface, might harbor liquid water, the cornerstone of life. Here, under the dim red glow of its star, could exist ecosystems unlike anything humanity has ever encountered. The exocompanion challenges our assumptions about what life needs to thrive. The star it orbits, though faint and cool compared to the Sun, emits powerful bursts of energy in the form of stellar flares. These flares, while potentially harmful, might also serve as a catalyst for prebiotic chemistry in the planet's atmosphere, driving the formation of complex organic molecules. If life exists on this twilight refuge, it may have adapted to these bursts of radiation, developing biochemistries that use the energy in novel ways. Such life forms might thrive in subterranean habitats or within protective layers of water, shielded from the harsh environment above. The surface of the crimson marvel might tell a story of resilience. Its rocky crust, shaped by billions of years of geological activity, could bear the scars of past impacts or the evidence of ongoing volcanism. Tectonic forces, driven by tidal heating, might have created towering mountain ranges, vast lava plains, or even deep fissures where geothermal activity provides a constant source of heat and nutrients. These geothermal hotspots could serve as havens for life, much like hydrothermal vents in Earth's oceans. The potential for such environments makes the reddish oasis a prime candidate for exploration and study. Beneath the surface of the tidal wonder, there may be hidden worlds of water and warmth. Subsurface oceans, heated by the planet's core, could remain liquid for billions of years, creating stable environments where life could flourish. These oceans, shielded from the radiation of the red dwarf star, might host ecosystems teeming with microbial life. If the exo-Earth harbors such hidden reservoirs, it would open new pathways for understanding how life might survive in the most unexpected places. The dusklit sphere also raises profound questions about atmospheric chemistry. Its atmosphere, if it exists, could be a delicate balance of gases shaped by volcanic activity, stellar radiation, and potential biological processes. Scientists are searching for biosignatures, gases like oxygen, methane, and ozone, that could signal the presence of life. However, even the absence of these gases would not mean the planet is lifeless, it could simply suggest that life there operates in ways unfamiliar to us. The Crimson Cradle forces us to expand our definitions of habitability and reconsider what life might look like on distant worlds. The Shadowed Cousin has also become a proving ground for cutting-edge technologies. Telescopes like the James Webb Space Telescope are pushing the limits of what can be observed from such vast distances, providing insights into the planet's atmospheric composition, temperature, and even surface properties. Future observatories, equipped with even more advanced instruments, will allow scientists to map the surface of the stellar neighbor, detect weather patterns, and search for the faint glimmers of light that might indicate liquid water or reflective ice. The alien ember is more than a scientific curiosity, it is a philosophical challenge. If life exists there, it would suggest that the processes leading to biology are universal, occurring wherever conditions allow. Such a discovery would transform our understanding of the universe, proving that Earth is not unique but part of a vast network of life-bearing worlds. Conversely, if the exotwin proves barren, it would underscore the rarity and preciousness of life on Earth, reminding us of the need to protect our fragile planet. The cultural impact of the reddish beacon cannot be overstated. Its discovery has inspired countless works of art, literature, and music, each exploring what it means for humanity to share the cosmos with other worlds. It has sparked debates about exploration, ethics, and our responsibility as stewards of both Earth and the universe. For many, the stellar echo represents hope, a reminder that the universe is vast and full of possibilities, waiting for us to reach out and discover them. The exosibling also fuels dreams of interstellar travel. Concepts like laser-driven light sails, fusion-powered spacecraft, and even wormhole travel are being developed with worlds like this in mind. One day, humanity may send probes or even crewed missions to this twilight jewel, turning speculation into reality. Such missions would mark the beginning of a new era in exploration, one where the boundaries of our solar system no longer constrain us. The Crimson Sanctuary, whether it harbors life or stands as a barren rock, is a testament to humanity's curiosity and determination. It is a reminder that the universe is vast, filled with worlds yet to be explored, each one holding the potential to reshape our understanding of existence. As scientists continue to study this cosmic mirror, they bring us closer to answering the age-old question: are we alone in the universe? The twilight enigma, forever circling its dim red star, is not merely a scientific subject but a vessel for humanity's greatest ambitions and deepest inquiries. It serves as a bridge between the known and the unknown, a point of convergence for science, philosophy, and the boundless potential of human imagination. Each new discovery about this crimson mystery propels us closer to understanding not only its nature but also the fundamental workings of life itself. The alien cradle, nestled in the delicate warmth of its star's habitable zone, is a reminder of the diversity of planetary systems. Unlike Earth, which orbits a stable and luminous sun, this stellar sibling exists under the flickering gaze of an ancient red dwarf. These stars are the most common type in the universe, accounting for over 70% of all stars in the Milky Way. If the reddish orb proves to be habitable or even inhabited, it would imply that life may be far more common than previously imagined, thriving around stars long overlooked in the search for extraterrestrial worlds. One of the most fascinating aspects of the exotwin is its potential adaptability to the unique challenges posed by its star. Red dwarfs emit most of their energy in the infrared spectrum, meaning that any life on the dusk-lit sphere would need to evolve mechanisms to harness this faint, red-hued light. Photosynthetic organisms, if they exist, might have pigments optimized to absorb infrared radiation, giving them a deep black or dark red appearance. These alien ecosystems, thriving under a perpetually dim sky, would transform our understanding of biology and its adaptability. The shadowed cousin also offers an opportunity to explore the role of water in shaping planetary habitability. While Earth is a water world, with over 70% of its surface covered by oceans, the Crimson Frontier might have a very different distribution of liquid water. On its perpetually frozen night side, vast ice caps could extend across the landscape, preserving water in solid form for eons. On the day side, any liquid water might exist in small, isolated pockets, heated by geothermal activity or concentrated sunlight near the equator. The twilight zone, however, offers the greatest promise, a region where water could exist in liquid form, flowing in rivers or pooling in shallow seas. These twilight seas could serve as cradles for life, rich with nutrients carried by weather patterns and geological processes. Beneath the surface of the tidal jewel, the possibility of subsurface oceans sparks endless speculation. If such oceans exist, they would be insulated from the harsh conditions above, maintained by the internal heat generated by tidal forces. These hidden seas could host ecosystems similar to those found in Earth's deep oceans, where hydrothermal vents support life entirely independent of sunlight. The reddish twin might harbor its own versions of these ecosystems, teeming with microbial life forms uniquely adapted to their alien environment. The exocompanion also challenges us to think about the long-term evolution of planets. Red dwarfs, unlike larger stars, burn their fuel at an incredibly slow rate, giving them lifespans that stretch into the trillions of years. This means that the Crimson Haven has had, and will continue to have, billions of years to evolve. If life exists there, it could be incredibly ancient, potentially predating life on Earth. Such longevity would allow for evolutionary paths and adaptations far beyond what we can currently imagine, offering a glimpse into life's potential over cosmic timescales. From a technological perspective, the stellar neighbor is pushing the boundaries of what humanity can achieve. Instruments like the James Webb Space Telescope have revolutionized our ability to study distant worlds, providing detailed data about the atmospheric composition and surface conditions of the Twilight Marvel. Upcoming missions, such as the Habitable Worlds Observatory, promise even greater insights, with the potential to detect weather patterns, volcanic activity, and even the chemical signatures of biological processes. These observations will not only reveal the secrets of this crimson anomaly but also refine our search for habitable worlds across the galaxy. The reddish sanctuary also serves as a proving ground for interstellar exploration. Concepts like Breakthrough Starshot, a project aimed at sending tiny, high-speed probes to nearby star systems, are being developed with worlds like this in mind. If successful, these probes could provide humanity with its first close-up images and data from the TRAPPIST-1 system, turning speculation about the alien ember into concrete knowledge. Such missions, while still in their infancy, represent humanity's first steps toward becoming an interstellar species. The dusk-lit orb also holds profound philosophical implications. Its very existence forces us to reconsider what it means to be alive and what defines a habitable world. If life is found there, it would prove that biology is not a cosmic anomaly but a natural consequence of planetary evolution. Such a discovery would forever alter our understanding of the universe and our place within it. On the other hand, if the shadowed world is barren despite its promising conditions, it would underscore the rarity and fragility of life, highlighting the importance of preserving and cherishing our own planet. Culturally, the stellar echo has already left an indelible mark. Its discovery has inspired countless works of art, literature, and music, each exploring the possibilities of life on an alien world. It has sparked debates about ethics, exploration, and our responsibilities as stewards of both Earth and the universe. For many, the exosibling represents hope, a reminder that the universe is vast and full of potential, waiting to be discovered. Ultimately, the Crimson Mystery is more than a distant planet, it is a reflection of humanity's enduring curiosity and ambition. As we continue to study this cosmic threshold, we inch closer to answering the most profound question of all: are we alone? Whether it proves to be a cradle of life or a silent, rocky world, the alien sanctuary will forever remain a symbol of humanity's unyielding desire to explore, to understand, and to dream. The Crimson Enigma, as it quietly traverses its eternal orbit around a dim red star, is more than a world, it is a beacon of possibility. This twilight cradle, locked in a delicate balance of light and shadow, continues to fuel the curiosity of humanity. The intricate interplay of forces shaping this distant planet, tidal locking, gravitational resonance, and stellar radiation, makes it a living experiment in understanding the diversity of worlds across the universe. With every passing day, our scientific tools and ambitions bring us closer to uncovering its secrets. The dusklit sanctuary stands as a stark contrast to Earth, yet it bears many parallels. Its rocky composition, size, and placement within the habitable zone make it one of the most Earth-like exoplanets ever discovered. However, its environment is far more extreme. The day side, permanently illuminated by the dim, reddish light of its star, could resemble a barren desert world, its surface scorched by heat. The night side, eternally locked in darkness, might be a frozen wasteland, its terrain coated in thick ice. But between these extremes lies the eternal twilight belt, a region of perpetual dawn and dusk where conditions might be just right for life. In this narrow band of habitability, the potential for liquid water transforms the alien frontier from an abstract concept into a tangible possibility. If water flows or pools along the Terminator line, it would open the door to ecosystems adapted to this unique environment. Here, life might take root in shallow seas or geothermal springs, thriving in conditions far removed from the cycles of sunlight and seasons that define life on Earth. The shadowed realm could host microbial ecosystems uniquely evolved to extract energy from chemical gradients, volcanic heat, or even the faint infrared glow of its star. The stellar kin is also a geological wonder. Its density suggests a core of heavy metals, much like Earth, surrounded by layers of silicate rock and possibly a thin atmosphere. Tidal heating, caused by the gravitational pull of neighboring planets, might create enough internal energy to fuel active volcanoes. These volcanoes, if present, could shape the surface of the Crimson sibling, spewing gases into the atmosphere and driving cycles of renewal that maintain a dynamic planet. The interplay between these processes, volcanism, atmospheric chemistry, and gravitational interactions, could sustain conditions favorable for life over billions of years. The exotwin also offers unique insights into the potential longevity of habitable environments. Red dwarf stars like TRAPPIST-1 burn their fuel incredibly slowly, with lifespans that stretch into the trillions of years. This means the Crimson Refuge has had, and will continue to have, vast stretches of time to evolve. If life has emerged there, it could be ancient, potentially predating life on Earth. Such longevity raises fascinating questions about the nature of evolution on long timescales. Would life stagnate, or would it develop into forms and complexities beyond our comprehension? One of the most intriguing aspects of the alien ember is its atmosphere, or the possibility thereof. Scientists believe that if this planet retains a significant atmosphere, it must have mechanisms to protect it from the volatile flares of its red dwarf star. A magnetic field, generated by a molten core, could shield the reddish mirror from stellar radiation, preserving its atmospheric integrity. This magnetic shield, if confirmed, would make the planet an even stronger candidate for habitability. Spectroscopic studies aim to detect the chemical composition of its atmosphere, searching for signs of carbon dioxide, methane, or oxygen, gases that might indicate volcanic activity, chemical cycles, or even life. The Crimson Outlier also serves as a focal point for humanity's aspirations in interstellar exploration. The TRAPPIST-1 system, located just 39 light-years away, is tantalizingly close in cosmic terms. Breakthroughs in propulsion technology, such as laser-driven light sails or antimatter engines, could one day allow us to send probes to this twilight marvel. These robotic explorers could capture high-resolution images of its surface, analyze its atmosphere, and even search for chemical traces of life. The possibility of reaching this stellar sibling within a human lifetime has transformed it from a distant curiosity into a realistic goal for the future. Culturally, the dusklit orb has sparked a wave of artistic and philosophical exploration. Writers imagine civilizations thriving in the twilight zone, adapting to the perpetual contrast of light and dark. Artists depict surreal landscapes bathed in crimson light, with alien skies stretching over jagged mountains or reflective seas. Philosophers debate the implications of finding, or not finding, life on this world. Would it confirm that we are not alone, or would it remind us of Earth's singularity and fragility? Either outcome would profoundly shape our understanding of existence. The Exocompanion also pushes the boundaries of our scientific tools. The James Webb Space Telescope is already providing the most detailed look yet at its atmosphere, searching for biosignatures and weather patterns. Future instruments, like the Habitable Worlds Observatory, will take this exploration further, offering direct imaging capabilities that could reveal surface features and climate dynamics. These technologies not only deepen our understanding of the stellar echo but also prepare us for the study of countless other worlds yet to be discovered. The reddish beacon continues to inspire humanity to dream bigger. It reminds us that the universe is vast, filled with worlds waiting to be explored, each with its own unique story. Whether it harbors life or remains a silent, rocky outpost, the Crimson Sanctuary challenges us to push the limits of what we know and to embrace the infinite possibilities of what we have yet to discover. The Crimson Marvel, quietly orbiting its faint red star, has become a symbol of humanity's relentless pursuit of knowledge. This twilight jewel, poised on the edge of habitability, is more than a distant planet. It is a profound opportunity to uncover the mechanisms that shape worlds and, perhaps, life itself. As scientific instruments grow ever more powerful, the secrets of this alien wonder begin to unravel, revealing a world that is both familiar and deeply alien. The stellar counterpart has already taught us much about the diversity of planetary systems. The TRAPPIST-1 system, compact and harmonious, challenges traditional models of planet formation and evolution. 7 Earth-sized worlds, including this reddish oasis, orbit their ultra-cool red dwarf star in a tight, synchronized rhythm. This resonance not only stabilizes their orbits but also generates tidal forces that shape their internal structures and geological activity. For the tidally locked orb, this gravitational interplay could be the key to sustaining a dynamic interior, fueling volcanism and potentially creating conditions for habitability. On the surface of this exosibling, the contrasts are stark. The day side, perpetually illuminated by the dim, reddish glow of its star, might be a barren landscape scorched by heat, with vast plains of cracked rock or even molten lava. The night side, shrouded in eternal darkness, could be a frozen expanse where ice stretches endlessly across the terrain. But the terminator zone, the narrow band of perpetual twilight where the two extremes meet, offers the greatest promise. Here, temperatures may remain stable enough for liquid water to exist, forming lakes, rivers, or even shallow seas. This twilight sanctuary could serve as the foundation for ecosystems uniquely adapted to the planet's eternal balance of light and dark. The Crimson Refuge is also a laboratory for studying atmospheric processes. If it possesses a significant atmosphere, it would need to withstand the challenges posed by its red dwarf star's frequent flares. These bursts of stellar radiation could strip away unprotected atmospheres, leaving the planet barren. However, the stellar echo might have developed defenses, perhaps a magnetic field generated by a molten core, or an atmosphere dense enough to absorb and redistribute the energy. Scientists are eager to understand how such a planet might maintain equilibrium under such harsh conditions, as this knowledge could reshape our understanding of habitability. Beneath the surface of the dusk-lit sphere, the possibility of subsurface oceans is particularly exciting. Tidal heating, driven by the gravitational pull of neighboring planets, could generate enough energy to keep water liquid beneath an icy crust. These hidden oceans, protected from the radiation of the star, might be teeming with life. On Earth, similar environments, such as the oceans beneath the ice of Europa or the hydrothermal vents in the deep sea, are rich with biodiversity. If the shadowed cradle hosts such environments, it would suggest that life could thrive in conditions far removed from the warmth of a sunlit surface. The exotwin also challenges us to expand our definitions of life and its potential adaptations. Any organisms on this world would need to survive under dim red light, extreme temperature gradients, and fluctuating radiation levels. Life on the reddish gem might rely on entirely different biochemistries, perhaps using chemical energy from geothermal vents or ultraviolet radiation from stellar flares. Photosynthetic organisms, if they exist, could evolve pigments optimized to absorb the infrared light of the star, giving them a dark, alien appearance. Such discoveries would redefine our understanding of biology and its resilience. The Crimson Anomaly has also become a focal point for technological advancement. The James Webb Space Telescope has already begun analyzing its atmosphere, searching for biosignatures like oxygen, methane, and water vapor. These molecules, if found in the right proportions, could indicate biological processes. Upcoming telescopes like the Extremely Large Telescope, ELT, and the Habitable Worlds Observatory will take these efforts further, enabling direct imaging of the stellar neighbor and revealing details about its surface, climate, and potential habitability. Interstellar exploration dreams are increasingly tied to the Twilight Beacon. Concepts like Breakthrough Starshot envision sending microprobes to the TRAPPIST-1 system, traveling at a fraction of the speed of light. These tiny, laser-powered spacecraft could reach the system within a few decades, capturing high-resolution images of the exocompanion and its neighbors. Such missions, though ambitious, represent humanity's first steps toward exploring worlds beyond our solar system, turning the alien frontier from a distant curiosity into a tangible destination. Philosophically, the shadowed twin forces us to confront profound questions about our place in the universe. If life is found there, it would confirm that the processes leading to biology are not unique to Earth but are instead universal phenomena. Such a discovery would have sweeping implications, suggesting that life is likely common throughout the cosmos. Conversely, if the Crimson Sphere is barren despite its promising conditions, it would underscore the extraordinary rarity of Earth and the fragility of its ecosystems. Either outcome reshapes our understanding of existence and deepens our appreciation for the delicate balance of life. Culturally, the reddish haven has ignited a wave of creativity and introspection. It has inspired artists to imagine surreal landscapes bathed in dim red light, where alien life thrives in harmony with the unique rhythms of the planet. Writers have crafted stories of civilizations adapting to the eternal division of light and dark, while philosophers debate the ethical implications of exploring, or interfering with, potentially inhabited worlds. The Crimson Sanctuary serves as both a scientific challenge and a wellspring of human expression, uniting people across disciplines and borders. Ultimately, the Twilight Marvel is a testament to humanity's boundless curiosity. It reminds us that the universe is vast, filled with worlds waiting to be explored, each holding the potential to transform our understanding of life, evolution, and the cosmos. Whether it harbors life or stands as a silent, rocky witness to the passage of time, the alien beacon will forever inspire us to look to the stars and dream of what lies beyond. WASP-76b is one of the most extreme exoplanets ever discovered. Orbiting its host star at an incredibly close distance, this ultra-hot Jupiter experiences temperatures so high that metals like iron vaporize in its atmosphere. With a surface temperature exceeding 2,400 degrees Celsius (4,352 degrees Fahrenheit) on the dayside, this exoplanet exists in a state of perpetual inferno, where molecules behave in ways unseen on Earth. One of the most fascinating aspects of WASP-76b is its weather. Scientists believe that iron condenses in its atmosphere, forming droplets that fall as molten iron rain on the cooler night side. The intense heat from the star, a yellow-white dwarf located 640 light-years away in the constellation Pisces, causes powerful winds to transport these metal vapors across the planet before they condense and fall as rain. This bizarre precipitation cycle is unlike anything in our solar system. The planet is tidally locked, meaning one hemisphere permanently faces the star while the other remains in eternal darkness. The temperature contrast between these two sides generates hurricane-force winds, circulating gases at speeds exceeding thousands of kilometers per hour. The night side, while cooler than the day side, is still scorching by Earth standards, with temperatures around 1,500 degrees Celsius (2,732 degrees Fahrenheit). Even on this cold side, the atmosphere remains turbulent, with chemical reactions that are still being studied by astronomers. Discovered in 2013 by the Wide-Angle Search for Planets (WASP) project, WASP-76b has become an essential target for next-generation telescopes like the James Webb Space Telescope (JWST). Spectroscopic studies have already detected traces of iron, calcium, and possibly other exotic elements in its upper atmosphere. These findings help scientists understand how extreme exoplanets evolve and whether their atmospheric compositions might provide clues about planet formation beyond our solar system. Despite its hellish conditions, WASP-76b is an important piece of the puzzle in understanding exoplanet diversity. It belongs to the category of ultra-hot Jupiters, a class of gas giants that orbit extremely close to their parent stars. Unlike the gas giants in our own solar system, which have relatively mild atmospheres, these planets are exposed to extreme radiation and heat, causing their atmospheres to expand and behave in unpredictable ways. Studying them allows researchers to test atmospheric models under conditions that would be impossible to replicate on Earth or even within our planetary neighborhood. As telescope technology advances, scientists hope to analyze the chemistry of WASP-76b in even greater detail, possibly identifying more exotic compounds or gaining insights into how such planets form and evolve. The discovery of metal vapor transport and iron rain on this world is just the beginning of what could be an entirely new chapter in planetary science, one where nature defies expectations and reality borders on science fiction. WASP-76b challenges our understanding of planetary atmospheres in ways that few other exoplanets do. Its extreme conditions push the boundaries of atmospheric physics, chemistry, and meteorology. Unlike Earth, where water drives the weather, this gas giant's climate is dictated by metal vapors and scorching winds. The discovery of iron rain was only the beginning. Scientists suspect that other exotic materials, such as titanium or vanadium oxides, could also exist in its atmosphere, forming high-altitude clouds or reacting with other elements in ways we have yet to fully comprehend. One of the most intriguing aspects of WASP-76b is the nature of its upper atmosphere. Observations from the European Southern Observatory's Very Large Telescope, VLT, indicate that the exoplanet stratosphere could be experiencing a form of metallic weathering. The intense radiation from its host star strips electrons from atoms, creating a layer of ionized gas, a phenomenon reminiscent of the plasma environments found in stellar atmospheres. This suggests that, at least in some ways, WASP-76b behaves more like a small star than a conventional planet. Another mystery concerns the planet's atmospheric dynamics. Theoretical models predict that ultra-hot Jupiters should have relatively uniform temperatures across their surfaces due to rapid atmospheric circulation, yet WASP-76b exhibits stark contrasts between its day and night hemispheres. Why doesn't heat distribute more evenly? Could there be unknown chemical reactions at play, or perhaps hidden atmospheric layers acting as thermal barriers? These questions remain unanswered, making WASP-76b a fascinating target for continued investigation. Recent studies using the Hubble Space Telescope and the James Webb Space Telescope, JWST, have hinted at additional complexities in the planet's atmosphere. Some spectral data suggest the possible presence of water vapor, though its survival in such an extreme environment remains a topic of debate. If confirmed, it would raise even more questions. Could ultra-hot Jupiters like WASP-76b possess transient or localized regions where water-based chemistry briefly occurs before being obliterated by the heat? The implications for exoplanet science would be profound, as it would mean that even in the most hostile environments, familiar molecules could still persist in unexpected ways. Another enigma is the long-term stability of WASP-76b itself. Given its extreme proximity to its parent star, tidal forces continuously distort its shape, potentially causing gradual atmospheric loss over time. Could this planet be slowly evaporating? Some ultra-hot Jupiters have been observed shedding their outer layers, forming comet-like tails of escaping gas. If WASP-76b is experiencing this kind of mass loss, it could provide key insights into how gas giants evolve under extreme stellar radiation. Perhaps the greatest scientific intrigue surrounding WASP-76b lies in the broader implications of its discovery. If iron can condense and rain down on this world, what other exotic weather patterns might exist on distant exoplanets? Could there be planets where molten quartz falls from the sky, or where atmospheric pressure is so intense that diamonds rain down like hailstones? Every discovery on WASP-76b adds another piece to the puzzle of planetary formation and evolution, pushing us closer to understanding the true diversity of worlds beyond our solar system. As telescopes become more powerful, the study of WASP-76b will continue to refine our models of planetary atmospheres. Its bizarre, nightmarish conditions serve as a reminder that the universe is far stranger than we ever imagined. The very existence of such a planet defies conventional expectations, challenging us to rethink the limits of planetary science and the nature of worlds that orbit distant stars. One of the most captivating questions surrounding WASP-76b is whether its extreme atmospheric processes could be a common feature among ultra-hot Jupiters, or if it represents an outlier among exoplanets. Recent observations suggest that many close-orbiting gas giants experience severe atmospheric stripping, but the presence of distinct metallic weather patterns, like iron rain, raises the possibility that WASP-76b harbors unique atmospheric chemistry. If iron can condense and fall as rain, could other elements, such as aluminum or silicon, also undergo similar phase transitions? Theoretical models suggest that ultra-hot Jupiters like WASP-76b could host exotic cloud formations composed of materials that would never condense on Earth. Some scientists speculate that titanium and vanadium oxides could form high-altitude clouds, reflecting portions of the star's radiation and influencing the planet's thermal structure in ways that defy traditional expectations. Understanding these atmospheric compositions could provide insights into the formation of gas giants both inside and outside our solar system. Another critical avenue of research focuses on the planet's atmospheric escape. WASP-76b is bombarded by intense ultraviolet and X-ray radiation from its host star, which could be slowly eroding its upper atmosphere. Astronomers have already detected escaping hydrogen and helium from other ultra-hot Jupiters, but whether WASP-76b is undergoing a similar process remains uncertain. If its atmosphere is gradually being stripped away, it could provide valuable clues about how gas giants evolve over millions or even billions of years. There is also the question of whether WASP-76b's atmosphere can